Okay, so let's look at some more uh, important points from this report. The report is nice and really long with fabulous list of references. I, as usual, do a short introduction to these topics, and you definitely want to follow up if you are interested. So, going ahead now from the executive summary to the actual details in the report. Why am I doing this? The mouse is very sensitive. This is the consequences of increased aridity on ecosystems and land degradation processes. Vegetation decline happens, soil disruption happens, and then systemic breakdown happens as a process continues, the aridification process. And you can see here the aridity index becomes larger and larger, so 0.54 0.69 to 0.83, in which case you are headed basically towards desertification. So you have the nitrogen content and the carbon content and the ability to fix nitrogen, etc., begin to diminish as far as vegetation functional abilities are concerned, and then you begin to have the soil disruption place. So you have ectomycorrhizal fungi that begin to die away, which you see a lot here, but they have basically disappeared here. And fungal pathogens are beginning to increase. There are fewer here, but you can see they begin to increase as aridity grows, and then albedo begins to change as well, which affects the energy budget and can be a feedback process, as we will see in a minute. Okay, so this is kind of a schematic, but you can read this paper by Verdugo and others from 2020 to understand the details behind the schematic, and this report has some details as well that I'm skipping. So figure 2 is showing the feedback loops in the system. So mechanisms and factors determining aridity, including feedbacks. So this is from a paper from 2021. Positive symbols indicate positive feedbacks, negative symbols mean negative feedbacks. The figure shows the relationship between physical and physiological drivers of climate aridity and the impacts related to water availability, vegetation, productivity, and socioeconomic systems. So we are looking at vapor pressure deficit, which is a very quick response to warming because the saturation humidity goes up and the available humidity is much lower, so you have a vapor pressure deficit, which means when leaves open they can lose much more water vapor very fast because of this pressure differential, and of course soil moisture can begin to disappear. Potential evapotranspiration demands go up as well, so that's potential evapotranspiration, which is directly related to the aridity index we are using. So let's say we have rising atmospheric CO2, which is happening. So you have physical forcing associated with that in terms of warming and water savings, stomatal closures, CO2 fertilization effect, where stomata is open to capture CO2. To save water, they have to close as fast as possible, but if CO2 is increasing, they don't have to stay open that long, so that's called CO2 fertilization, and there's a lot of good literature on that. You have also radiative forcing, and you have positive feedbacks with temperature and vapor pressure deficit, which obviously affects vegetation productivity with higher water demand, stomatal closure effects, vegetation climate feedbacks as well. Okay, so this could be a negative feedback, but some of them we don't know. For example, higher water demand and stomatal closure with higher CO2 can be negative feedback. In other words, vegetation can support some of the reduction in vapor pressure deficit, but that's bad news for the vegetation, of course. Precipitation changes happen, glacier melt is already happening, which also can have negative feedback to vapor pressure deficit, increased potential evapotranspiration, soil moisture vapor pressure deficit feedbacks happen. So I won't go into the details, but you just note the number of feedback loops, and some we don't know, some we think are positive. So temperature obviously increase. If temperature increases, vapor pressure deficit increases for sure. What will happen to precipitation is not clear, but that can have impact on glacial melting, because if snowfall goes down and temperatures go up, glacial melt goes up because albedo effect can accelerate as well, and so on and so forth. Socioeconomic systems, water consumption by crops through transpiration, competition for water resources, of course, and you have root water uptake for transpiration. Runoff is going to be affected, water yield to soil moisture, infiltration, groundwater recharge. Then you have human activities like irrigation, domestic and industrial use, hydropower generation, etc., that are competing for agricultural use, irrigation use, domestic use, and industrial use, which can obviously exacerbate the already bad situation. Looking at the trends here, difference between aridity index values over 1961 to 1990 versus 1991 to 2020, you can see there are you are subtracting 1991 to 2020 minus 1961 1990. So obviously there are large number of regions where aridity index is getting worse, right? So very few regions where you actually have increased precipitation compared to potential evapotranspiration demand. So as I said, the warming over here is causing wind shifts over here, causing extreme rainfall over northwest India and Pakistan, and there are other regions here as well. So this is now looking at, so let's just see what is. Green means weather conditions, brown drier conditions. So Greenland is masked in the upper panel as the AI shows large variations due to snow. Lower panel shows shifts between AI classes in the above mentioned periods. So you are looking at humid drylands with drier class, drylands with the same class, drylands with wetter classes, and drylands with humid shifts, which corresponds to these, but more in terms of the classification, which let's not worry about right now. Okay, but news is not good. You can also look at it in terms of annual percentage of dryland, and remember, this is historic period, this is not projection, so this is data, this is actually what already is happening. The annual percentage of drylands and population in drylands from 1971 to 2020. So without going into details, you can see that populations have grown, and that's the lilac bars here, and global billions in millions, sorry, why don't I read it? Population totals in lilac bars in million people, but for global, that is a billion people, the values are smoothed with an additional 10-year moving average. Global drylands are computed excluding Antarctica. So you have North America, Europe, Asia, global here. So this for global populations are in billions, for these regions it's in millions. The scales are not visible, sorry about that. The quality of the figure itself, I have to zoom it to a big scale to see the big size, to see the scales, but you get the idea. This is the Latin America and the Caribbean, Africa and Oceania and Australia. The message is relatively clear, right? Global map of 6 aridity index classes for 1991 to 2020. The boxes show the total percentage of global lands and population within each AI class and within drylands versus non-drylands. Antarctica falls entirely in the cold class and is not included in the map or in the percentages. There is a way to compute aridity index for glacial regions as well, because you can look at snowfall, which is precipitation, but then you have to define what is evapotranspiration, potential evapotranspiration, because if there is no vegetation, you will need to modify it. So anyway, you can, this is for global, but there are also regional maps provided in the report. So you have hyperarid, arid, semi-arid, dry, subhumid, humid and cold regions. So obviously Antarctica falls in cold, but we already mentioned all the regions that are showing strong trends for the last 3 decades compared to the previous 3 decades. So 1991 to 2020 compared to 1961 to 1990, right? So a diagram of cascading impacts and interactions among different socioeconomic and environmental processes affected by aridity. Arrows indicate the direction of the effect, and plus and minus symbols, of course, are increasing and decreasing severities. I'm jumping ahead, as you can imagine, because I went here from figure 6 to figure 16. Climate aridification is land degradation, land cover reduction, soil erosion, sand and dust storms, and human health impacts all are positive, so worsening. And here you have ecosystem alterations, biodiversity loss, and wildfires increase. And climate aridification directly feeds into wildfires as well, which can of course feed into human health impacts. And climate aridification also creates water scarcity, which affects agricultural production and poverty, food security, human migration, forced displacements, which also is affected by health impacts and by sand and dust storms, right? So you also get soil erosion impacts on water scarcity because of soil water loss, retention capacity, vegetation loss, groundwater recharge, and so on and so forth. A map of aridity related impacts based on the literature review. So this was a meta study part of this report. Each pictogram indicates a study that describes. So I won't go into the details. I just wanted to point out the kind of impacts that are studied by the number of papers that the meta study here looked at. Agriculture and pastoralism, desertification, health issues, migration, poverty, STS, water resources, wildlife and ecosystems, so forests and biodiversity. SDS, I just read it and I should remember it, and obviously I'm getting old and I forget. So let's look it up quickly because it's lazy on my part not to write it down. SDS, it is sand and dust storm. Okay. So many acronyms, I read them and I think I will remember it. I don't need to note it down, but then I forget, right? So these are 5 integrated policy areas. There are lots of other details that I skipped here in terms of the types of aridities and impacts. 5 integrated policy, oops, no, that's not what I meant to do. And policy recommendations they include for addressing the challenge of current and future rising aridity. Establish aridity monitoring with existing resources and UN cooperation for better existing resources and UN cooperation for better early warnings in water and related sectors. Early warnings are lifesavers. Big fan. I am a big fan, and I have course on subseasonal to seasonal predictions and early warnings for health, water, etc. Standardize aridity assessments with data sharing and advanced technologies. So you have the 5 pillars here, or integrated policy areas. Aridity monitoring. Unless you are monitoring it, you don't know what the trends are and what the adaptation measures should be, etc. Aridity impact framework, aridity governance and collaboration. Sorry, I went jumping around here. Aridity impact framework here. Integrate aridity and drought plans. Combat land degradation and improve aridity resilience. And here aridity governance and collaboration. So what is under each one? Under aridity monitoring, we already said what needs to be done. For aridity impact framework, develop a global standard for assessing aridity impacts so that all the international negotiations and international evaluations and assessment reports can be uniform. Implement guidelines that prioritize temporal and spatial monitoring and adaptation methods. Transferable solutions are possible when you have global standards, and best practices can be moved around quickly. Establish, under aridity governance and collaboration, establish a multi-level governance framework integrating aridity adaptation and risk reduction efforts. Remember, vulnerability and climate impacts are very local, hyper-local in many cases. So you will need, even within a country or within a subdivision of a country, you will need multi-level governance framework. Encourage public-private partnerships to mobilize resources for innovative and sustainable land management projects. There's a broader framework there as well, how to basically make land use management as part of enhancing the natural sinks of carbon and reducing the sources of carbon as well, for reducing forest degradation, deforestation, protecting forests, various other practices, natural climate-based solutions, and so on. Sorry, I went to 5 over there, but it doesn't matter. Integrate aridity and drought plans. Consolidate aridity, adaptation, and drought planning. So drought is shorter term, but you can have repeated droughts with decadal shifts, which will result in aridity as well, right? Integrate sectoral plans into national adaptation strategies. All countries are now required to have a national adaptation plan. Many countries have submitted, and they have to be flexible and be updated and have to be mainstreamed into the fiscal policies and budgets, so that funding is sustained as well for these purposes, like dealing with aridification by integrating aridity and drought plans. Under combating land degradation and improving aridity resilience, prioritize sustainable land use planning to address land degradation worsened by aridity. Incentivize adoption of conservation, agriculture, and forestry through policy and market incentives. So they are broad guidelines, but obviously implementation at local scales, regional scales within the country, across borders, because aridity is spreading across borders in many places. Displacements happen across borders, and you need data sharing, monitoring plans, adaptation plans. You cannot adapt, let's say, in Pakistan and not do it in Northwest India, which is closely associated, physical border. Geographical unity of the region has to be kept in mind, because climate change doesn't care about boundaries, and the impacts don't care about the boundaries. So the more we deal with these as integrated regions with integrated monitoring, evaluation, adaptation plans, governance shared somehow, then it'll fail. You cannot just make one part of the arid land resilient and leave the other one as it is, because the entire system is only as resilient as the weakest link in that system, right? So these are general words, but you can imagine implementing these is going to be very tricky when there is no trust between the entities across the border. Okay, so let's leave it here. It's a nice report, as I said. You need to go back and read if you are interested in the details, and I am very brief on these as usual, but I pick the most salient points based on my own judgment, which may not be the same as your judgment. And some people argue that I'm not an expert on these topics, so I must be more careful, and I try to be, but as an introduction this should be useful, right? If not, let me know, right? Send a message. Hey, see you in the next topic.